There you go.
Okay, so there are two possibilities. My presentation is a Prezi demo, so I can remote present it, and everyone can follow on the Prezi website. I could give you the URL in the chat, or I can share the screen, but I think sharing the screen would be less legible. So which do you prefer?
I think we would prefer if you could share the screen, because we are recording it for others, and then that will record you navigating on your screen. And those of us on our end can just increase to full screen, and we should have a good view.
Okay.
So I would prefer to try that if we could.
Okay, let's try that. So I can, okay, so do you
Yeah, that looks great.
Okay, it's good?
Yeah, that looks great. Thank you.
Okay, let's go. So our platform is called Pivage, which is French for newspapers, archives, indexing, and visualization platform. In order to help you understand where we come from, I will go back in time a little to 2010 to present our first prototype, and then I will go further and describe our second prototype and our latest advances, if it's all right. So this is the first issue of Le Journal de Rouen. It dates back from 1764. This is the year where Marie Antoinette met Mozart in Vienna, and Mozart fell in love with her. This is another issue from 1812, which is a year that started very well for Napoleon Bonaparte and ended very poorly for him. 1842, where nothing historically significant happened, but a lot of small stories, weddings, funerals, and a lot of local history, which is really the stuff that, in our experience, users are looking for in historical newspapers. So what we are trying to do is starting from do digitization and trying to extract information from them. Oops, sorry. We want to augment the images with data. We want to augment it with the structure of the document, display the sections, the articles, the pictures, and augment the image with content, which is, for example, transcriptions or named entities. So we started in 2009 to work with existing free software technology, including double IP image, which is one of the maybe technological ancestors of what is currently used in IIIF. And we applied what our skills to the matter. So we are LITIS, we are an academic computer science research unit from Normandy. And we have longish experience in document image analysis using artificial intelligence, pattern recognition, and machine learning. So it brought us to the first prototype of Pivage. Where, well, nothing extraordinary for the moment. we can browse newspaper images with a zoom control that wasn't too shabby in 2010. It's not as fluid as current deep zoom, but it was still using the same tricks of using pyramidal TIFFs. So, of course, this part of the video is not very interesting for you. You all know that. We can switch pages, navigate issue by issue, and navigate by articles, what we call articles. We can, these articles are automatically extracted by our back office, and we can also browse them in the viewer. Which leads us to another functionality. We have, of course, an OCR of the articles, and we can find articles by entering keywords, filtering them, sorting them, this sort of thing. As the transcription is alto aligned with the picture, we can highlight the results in the text and in the image and correct the transcription, which needs it because our partner had small budget and paid for a cheap OCR. So building a crowdsourcing into the system was very useful to correct it. The crowdsourcing correction aligns the image and the text to allow for an easier correction. And the indexing is real time, meaning every time something is corrected, it is immediately indexed. I just corrected in the video the word empereur, and if I look for it, I find it immediately. Okay, so we opened our prototype to a general audience in 2012. It wasn't, I think, too bad. The display interface. Yes, I don't know. Yeah, we could navigate within our hierarchy, and we improved indexing through crowdsourced text corrections. Okay, now about everyone do that. Okay, so well, we were a research unit, but we displayed, we gave access to this journal to try to check how resistant it was to real usage. So we have about 1,500 users a day, a month, to see if how it works. Okay. So in Pivage 1, we went from pixels to articles, but quickly, when we tried to validate our article extraction, we noticed that not everyone means the same thing by articles. For example, in this issue of Le Journal des Débats, you can see that all this part is called Nouvelles étrangères, which is foreign news. Then it is separated by country, and then by town. But what is an article? Is Milan the article? Is it Italy the articles? Or is foreign news the articles? There is I am not aware of a definitive answer to this question, but what is sure is that people all agree that Milan is inside the Italy section, which is inside the foreign news sections. So what we aimed at doing was trying to find the outline of the newspaper, the way the sections contain sections, etc., and calling maybe articles or piece of articles the lowest part of this hierarchy. So how does it work? We use a machine learning architecture, which means that we must first build by hand examples of what we want, and then the system will learn and try to make its own analysis. This is what our physical layout editor looks like. We start with an image of one page. We provide some basic corrections, but we have also automatic correction. We'll see that later. And then we delineate the different section of the page. Here, vertical separator, the horizontal one. Okay, let's go faster. We surround the text area. And we also give a level, a headline level, to different text area. So this is title 2. So this, in green, we have the body text. And now, headline of level 3 for the subtitles, etc. And then we have one page of ground truth. We need more of them. And we give them to our learning architecture that does the following things. First, some automatic picture correction, skew, crop, and then it tries to detect separators, text, pictures. You can, I'm not sure it's readable through the video, but you can see near the bounding boxes, title 2, title 3, body, etc. I'm not sure if it's readable. Then we, from that, we extract the physical layout, try to find the reading order, and then the text hierarchy. And from that, we can find the sections. I think I have an extra zoom. Yes. You can see it's the same page I used as an example previously. You can see in gray the lowest part, which is foreign news. On top of it, you've got the green Spain with light green Madrid. And then nearby in blue Italy with light blue Naples, Milan, etc. We also tried it on, of course, more complicated layout than what I've just shown you. For example, this issue of Le Petit Parisien with 6 columns, pictures. and it worked quite honestly. You can see, for example, the central red article, Un assaut franco-italien, where it assembled the title, the subtitle, and the part of the articles, including the pictures, until the next article. Or beneath, you can see L'appareil Boireau, which is an article on 2 columns in the middle of 2 separate columns, but that were correctly assembled. And other examples. On this example, you can see one of our weaknesses, ads, advertising. We are really poor at advertising because it does not, our analysis is purely graphical. We do not use any semantic. We nearly do not use any thing from the text. So when something does not respect at all the way the rest of the newspaper is written, like ads often are with different typography, our systems is just does not work properly on these kind of things. Okay, so this is the whole process. The first step is manual, and then the rest is automatic. You must manually, for one newspaper, describe between 10 to 20 pages, and then automatically you can treat thousands of pages. Precisely, there are no hard limit on the change, on the graphical change it can take, because newspapers layout evolve during time, but quite often you can do about 10 years of daily newspapers before you need to give him a better ground truth, more adapted to the new graphical layout. But for example, we can nonetheless, we've tried it, learn on 2 or 3 columns and test it on 6 columns and obtain quite correct results. Of course, it would have been better if we had learned it on real 6 columns. It's a balance that must be struck between manual work and the quality of the automatic learning. Okay, OCR. So in our system, you can plug any OCR, and we are currently developing our own. It outputs an alto file from the structural analysis and the transcription, and a METS file per issue. This is where we store the logical structure, the sections, the articles, in the logical map of the METS file. What else? Yes, some tiny bit of information. I said we nearly do not use the text because we use it for footnotes and for continued on page to build, to stitch together parts of articles. For footnotes, we need to read, for example, bracket, one bracket, to connect it correctly to the right part of the text. Oh, sorry, I had one zoom for each of these steps. So this is what our second prototype looks like. So it's not currently publicized. We are the only one who are using it. It's still being developed. So you can see a section, the different parts of an articles. You can navigate the different parts in the graphical section or in the textual transcription. And you can also stitch the different parts of an article together, right beneath one another, which can be handy when an article is spread on many pages. It's easier for the reading. It's just an experiment we did to see if it had any interest. And this ends my presentation. I hope I was clear enough, and otherwise I welcome your questions. I will try to understand them and reply.